Perfect. So I'm excited to be here. Thank you for having me here. Don't expect too much. I'm an economist more than anything else. If anything, a very applied econometrician, and this is a very applied paper. So don't be too disappointed if you don't see any econometric theory in this paper. There might be economic theory if we have time for that, right? I'm not sure you will appreciate that, but I hope that you will still be able to relate to the paper on a very personal level, because the topic is quite approachable in the sense that it's a paper about life, namely the geography of life. Now, life is a bold title, so let me kind of narrow down a little bit what I will refer to when I speak about life. Essentially, I'm going to talk about circumstances of life, and the circumstances of life will depend on two things that relate to all of us. For one thing, we age, right? So you kind of progress through life by aging, if you're lucky, I guess, right? At some point, your aging obviously comes to an end. And then along your kind of your progression through life, you will experience seminal life events. Loads of them we have in the paper. You can think of about things like marriage, having children, retiring, and many, many more life events. And these two things, right? I mean, let's say life events and aging lead to changes in your circumstances of life, which obviously will have large effects on economic decision making. And of course, economists have thought about certain dimensions, certain type of economic decisions. I guess the main fields that come into mind are finance, where people think about intertemporal smoothing of consumption. Later economists think, okay, if you get older, if female workers have children, how does labor force participation change? All of these are important questions. We will focus on the geography of life, okay? Which surprisingly perhaps is an area where we know very little about circumstances of life being determinants of economic decisions, which I think is maybe surprising, because intuitively, if you think about yourself, right, as you have children or other things change in your life, it's very likely that you will perceive good places of work and good places of residence to change accordingly, right? If you think about the city, just in a cross section, right? I mean, you can immediately think of neighborhoods, I guess, where you see that people are young and cool, and other places people are posh and maybe a bit more senior, right? And we know relatively little about the driving forces, right, behind these locational choices. And that's a gap in the literature that we want to fill. From a planning perspective, it's important to fill this gap because Germany and many other countries around the world is undergoing very heavy demographic changes. We're getting older on average. We're having fewer kids. We have more singles. And of course, if you kind of extrapolate that to the next 100 years or so, I mean, this may change heavily demand for space within cities and potentially even between cities. And it's of course important for planners to know roughly, right, in which direction the demand structure within cities is evolving, so that we can start thinking ahead about investments into true capital like let's say, transport infrastructures, schools, and so on and so forth, right? So that's the purpose of this paper, really kind of understanding the mechanisms behind the spatial sorting of people depending on their circumstances of life. What do we do concretely? It's mainly an empirical paper, right? We have a quantitative model to talk about mechanisms, but mainly it is an empirical paper. It uses a hell lot of data, right? And maybe the most exciting thing about the paper in the sense is that we have a new data set, which I don't think existed before. So what we use in this paper is a comprehensive employer, employee, property, family data set. So we work with Danish data, and we know really for all Danes, every Dane, there's no restriction like in the German social security data to people who have a job contributing to social security. We would observe anyone, whether they are civil servants, self-employed, students, kids, right? We know, just like you would observe in the IAB data, so that's maybe the closest thing that you have in Germany, an employer-employee data set, so you know where people work, where people live, you know the company they work for, you know the wage they earn, you have the gender, some information about skills and so on and so forth, right? You know some information about the firm too. On top of that, we can match this employee-employer data set, which is something that is fairly standard. You have that for many countries, right? But what is already not standard is that we can merge that to the property, right? So we know exactly in what property people are living in. By property, I don't mean the address, I mean the flat. So we would know exactly you live in the 5th floor and you consume 80 meters of square footage or something, or square meters. And this is very helpful because this allows us to also then kind of build a proxy for how much income, what a fraction of your income you're spending actually on housing, right? So we know that, right? And then we have the entire family information. We can observe whether people live together in one household. We know actually who your parents are, who your kids are you living with the kids, and so on and so forth, right? So this is a very rich data set. Again, as I said, the universe of veins are in the data set, and we observe them repeatedly over 30 years. Okay, econometrically, that's very convenient because when you think about cross-sectional sorting within cities, right, it could always be that people have different, or sort into different places, have different preferences for certain locations because they are in different circumstances of life. But it could also be that there's some unobserved heterogeneity about these workers that are just correlated with that. Maybe older people have on average higher incomes or specific tastes for certain things, whatever, right? But because we observe these individual workers, over time, we can use panel econometric techniques to separate the unobserved individual component, right, from, let's say, the causal effects of aging and life events, if you want to call them causal, right? So with a data set like that, you start descriptively, I would say, right? I mean, this is a very new data set, it's a new question. So the duty of the researcher is to kind of look at this with relatively descriptive techniques. We then are also going to kind of do a little bit of event studies, right? I mean, to tease out, I mean, something that is not really causal, but maybe closer to causal, something like what happens when you have a child controlling for all other life events, right? I mean, this is going to be also happening in the reduced form. And then eventually, us being quantitative spatial economists, what we're going to do, we're going to use a parametric model, right? We're going to quantify it by estimating a bunch of parameters, and then we're going to use the model to decompose, right? I mean, the determinants of locational choices, right? To different mechanisms to then kind of tell you what really is driving people in different circumstances of life into different parts of cities, right? And then eventually we can use the model. Now it's a general equilibrium model, suitable for, let's say, out of sample long-run predictions. Economists would argue we ask the model how the structure of a city will change in the very long run if the demographic structure of the city changes. So that's roughly what we want to do. I mean, maybe if something's unclear at that point, we may start asking your questions. No? Okay. Feel free to interrupt me anytime. Economists, they tend to kind of interrupt us all the time, so I get a little confused if nobody asks questions along the way. But maybe that gives us a chance to finish the presentation, which would actually be the first time I ever finish this presentation in time, because people usually kind of jump in and ask so many questions because they relate to these different aspects of life in the way that they become curious or skeptical of what we do. So let's see how it goes today. So what do we find? I mean, maybe in case I don't make it to the end, it's useful to kind of highlight a couple of major insights that arise from our empirical analysis. Yeah, I think I'm going to skip that maybe here, right? I mean, one thing that comes out of a very basic empirical exercise is that people are a lot more mobile within cities than between cities, and they are much more mobile at the workplace than at the residence, right? Life events turn out to be important. So when you think about it, I mean, there's going to be a life cycle in location choices, which is going to be very intuitive. You are born with your parents in certain parts of the city, then you kind of move to the center, then you move to the suburbs again, right? I mean, that's going to be the main story. And part of that is going to be driven by life events like having children, but it's also going to be a strong component arising just from the fact that you age. Mechanisms, right? Maybe this is the most economic insight here. What's going to come out eventually is that the main driver for why at different stages of your life you want to live in different locations is your taste for amenities. Okay, so just kind of to preview what we're going to find. Intuitively, you can think of many reasons for why you want to be close to the city center or far away. This can be related to your perception of commuting costs. This can be related to your job opportunities. This could be related to the distribution, your preferences for, let's say, jobs, right? But another explanation is simply that at a certain stage of your life, you need some amenities like bars and restaurants nearby. At another stage of your life, you want to have nice playgrounds, right? And at yet another stage, you may have something like forests or access to natural amenities in mind, right? And eventually it turns out, right, I mean, that these amenity preferences and the way they change over time, they seem to be the main driving force of changes in location choices over the life cycle. And yeah, in terms of demographic change, right, I mean, the main insight is going to be that individually, all of the three mega trends that I mentioned, right, lower fertility rate, average aging, and also greater singlehood, they have major impacts on the structure, on the spatial structure of cities, but jointly, they kind of offset each other in ways that are likely going to make cities relatively resilient, right? So we don't have to have the very, or at least it's not obvious that we have to imagine certain parts of the city because of these demographic changes suffering some kind of catastrophic decline in demand, right? So that's some kind of interesting insight that comes from the simulations. Yeah, the results, the literature, I mean, I think it suffices to say here, what we're doing here is pretty novel, right? I don't think anyone has done something similar before. I mean, at least not in such a comprehensive way, covering life, as I explained it, as broadly as we do. So going to skip that. That's the structure. Let's skip that too. And let's just kind of look quickly at the empirical setting. I mean, mostly we are going to focus on Copenhagen, not necessarily because we have to. We have the data for all of Denmark, but it's mainly our choice to kind of focus on location decisions within cities, because it turns out that mobility within cities is much greater, and then Copenhagen doesn't have so many cities that we would consider real cities, right? I mean, so Copenhagen is arguably the only city that kind of by international standards satisfies that definition. So we focus on Copenhagen. This is Copenhagen the way you would perceive it as a tourist or someone who goes there for a business trip. So you have here in the middle, you have the city center. In the south, you have the airport, right? And then what we use as our definition in the data, because we need to crop Copenhagen in some way, is something which is much bigger than that. So what you saw before was roughly the dark blue area. We are going to use the light blue area, which is really a large area. I mean, the light blue area would be something like, we checked it, I think it's 3,000 square kilometers. In comparison, Berlin has slightly less than 1,000. And Copenhagen has way fewer people, right? I mean, so this is a very generous definition, and the reason why we choose that to crop the data is simply that you don't have to worry about, okay, is someone living in Copenhagen and working outside Copenhagen? Is someone working in Copenhagen, living outside? I mean, this area is sufficiently large that basically there is no issue of commuting across the border. And I'm actually waiting for one question regarding commuting. Usually, people typically ask in the Copenhagen context, commuting in and out. Nobody's coming up with. Sometimes people, I mean, almost always they ask about commuting here in this direction over the bridge to Malmö, because there's a big city close to Copenhagen. But it turns out these flows are super tiny. I mean, I was surprised by that. I mean, even in the latest year, the commuting flows have gone up a little bit. It's less than 15,000 people per day who cross the bridge, which apparently has something to do with the fact that the bridge is still pretty expensive to cross, right? I mean, at some point they're going to they're collecting tolls to pay for the bridge, which will happen after a certain number of years. And after that, they're going to lower the tolls, and then that might be a nice natural experiment to see how commuting flows then increase. Until now, not much action going on the commuting to Sweden. Okay, a bit more on data. So the panel that we have, I mentioned, it's a pretty long panel. By the standards of such data sets, it starts in 1986 and we go all the way to 2019. Then comes COVID, and you kind of wonder whether you want to keep those COVID years in a data set or not, right? I mean, so far we haven't included them, but we could, and maybe at some point we will extend that a bit further. was also making fun already about the the length of papers in terms of time, right? That economists spend writing. I mean, I have papers that take 10 to 15 years to finish, right? So, I mean, inevitably, I guess, at some point, this data set will be outdated enough to warrant a kind of a revamp and an extension of the time frame. Let's see when this will happen. Now, for all these workers, which we observe on a yearly basis, for all these years from 1986 to 2019, we know where they live and work. Now comes a critical choice that you have to make. These data sets, you can imagine, right? I mean, they are not easy to access, right? Because of confidentiality restrictions, right? The way it works, you actually have to buy a server, right? And you put the rack into the office, into the basement of Statistics Denmark. There's no way of getting data in and out. Essentially, when we put our big transport cost matrix, it's actually on the server. Ismir goes there with the hard drive, hands over the hard drive to the guy at Statistics Denmark. They check the hard drive for 3-4 weeks, and then eventually, once it's clear, they put the stuff actually onto the server, and getting results out of the server is similarly complicated. Getting data out, tables, maps, it's ever more complicated the greater the spatial resolution is, right? Because obviously, the smaller your cells, the fewer people you will have in these cells. And so you need to make a choice, a wise choice. Have your cells small enough so that you can work at high spatial granularity, so you know a lot about the spatial location. At the same time, you don't want to make it too small, because otherwise you're going to have all these confidentiality issues all the time. So we choose as a spatial precision a grid of 100 by 100 meters, which is, I mean, super detailed. And yet, at least in the central parts of the city, right, I mean, you're going to have at least dozens, if you're lucky, sometimes maybe even hundreds of people in these cells, which then kind of avoids any concerns about confidentiality. Yeah, I mentioned already, right? I mean, we have wage and non-wage income, which is cool. We don't fully exploit that, right? I mean, but we also know actually capital incomes, pensions, and so on and so forth. I mean, of course, we know the education of people and the sector of employment. If they are working, right? We also know if they are students. We know the size and type of residence, and we compute a real estate price index, which allows then us to compute how much people are spending explicitly in terms of rent, or implicitly as imputed rent if they are homeowners, on their space consumption. And then we have the family status, especially we know actually how old the children are, how many they have. Marital status, we keep saying that, although in Copenhagen, the official word is cohabitation. Marriage apparently is not very important. There is kind of a official definition of living together, which is called cohabitation. And with that cohabitation come actually all the relevant legal privileges. Whether you're married or not actually doesn't make much of a difference. So I should actually say cohabitation rather than whether you're married or not. And as I said before, right, I mean, we have the data for the other parts of Denmark, but we don't use it so much, except for this year. I think that's very simple, but still quite informative. And I think this part relatively original graph. So we compute something as simple as the probability of changing your residence or your workplace in a certain year, right? So what this is telling you here, that young people have an astonishingly high probability of nearly 40% to change their workplace and their residence within a year. And then, of course, this probability changes as you age, and the residential mobility declines faster than the workplace mobility. And this graph here answers the question, conditional on moving, conditional on changing your home or your workplace address, will you change within the city, or will you change your location within the city? Will you change the neighborhood, or will you change the city? Will you move to another city? And here you see that actually 8 to 9%, irrespectively of age, if they move, they actually make a move within the city, and a relatively small fraction changes cities, which to us suggests that maybe the first paper you want to write is a paper about location choices within cities, although you could also write a paper about location choices between cities. One thing I should add here, I don't think I have that here in as backup slide, no. So what I can tell you, the obvious thought that comes into mind is, okay, maybe that's Copenhagen specific. Copenhagen is a large city, so a large fraction of people moves within cities. But you can do that for all the other cities in Denmark, some of which are very small, and you basically get the same fraction, even in Aalborg and in Eisberg and Odense, all these small cities, still 80 to 90% move within the city if they move. So I think the story of life and location choices really is one of location choices within cities, not so much between cities. Cool. Okay, so let's accept that people are moving mainly within cities, and now let's spend a little bit of time on these super simple yet pretty interesting descriptive graphs, which give you a sense of how life and the location, associated location decisions evolve, at least in Copenhagen and possibly elsewhere, that I don't know, right? So focus on the upper left graph. That's a super simple graph. So all we're doing here, take the black line, we are computing simple conditional means, right? Basically just taking a 1 year age and just saying, okay, what's the average distance from the city center where you live for the group of people who are 20 years old. And then the next one will be 21, 22, 23. There's no kernel smoothing going on here. The reason why this looks incredibly smooth is because there are just a lot of data points, right? So these are about 1.5 million Copenhagans, and then we pool that over 30 cohorts. So something like 45 million observations go into this black line, right? And if you have enough observations, and everything becomes very smooth. And what this tells you is that kids, right, when they are basically more or less still at home, they live where their parents live, right? Then as they progress in life, right, I mean, they move significantly closer to the city center, right? Something seems to be exciting about the city center. Maybe that's a good place to do fun stuff when you're young. Maybe that's a good place where you can meet someone to mate, right? And then at some point they start having children and they become just like their parents, right, and move back to the suburbs, okay? And then there is a little bit of a plateau, the black line, and then we see something falling off here. So the black line suggests that as we move to older cohorts, we start seeing that people are living closer to the city center. It turns out that this is purely driven by a cohort effect. Do I have the... no, I think I should. It's unfortunate that I don't have the backup slide here with the different cohorts, but we created this black line for different cohorts, and then if you kind of look at older cohorts, you see exactly the same pattern. It's just that it's shifted downwards, right? So it's exactly as you said. I mean, the now old people used to be young a couple of decades ago. A couple of decades ago, Copenhagen was a lot smarter. Therefore, you have a composition effect. This composition effect you get rid of if you now estimate these conditional means, conditional on individual fixed effects. Okay, now we move to a paneled econometric world, right, in which we track workers over time. So comparisons in this red dotted line, right, they purely come from changes in individual behavior within individuals, right? So composition is taken out, and if you take out this composition effect, then this sorting effect, which arises from heterogeneity across cohorts, that completely disappears. So what you see, people, yes, they still move to the center to experience something exciting, then they move out, become just like their parents, and as they age, if anything, they move further and further and further out, right? So that is why for us it is actually very useful to have this kind of panel dimension to take into account this unobserved heterogeneity that is related to cohorts and possibly other things. For distance to the workplace, you see this composition effect is not so important. You have a similar pattern, right? I mean, you suburbanize, first you centralize your life in terms of jobs and residence. Yes, that makes sense, right? I mean, if you're very young, you probably do some kind of minor jobs that you can do close to your home, like, I don't know, distributing post or whatever, right? And then you get a proper job that's usually in the city center. So I should say that Copenhagen is really a stereotypical monocentric city where you have most of the good jobs in particular, but most of the jobs in general in the city center. So when you move to the city center, you usually kind of upgrade your job, right? And then at some point, when you suburbanize your life, you also suburbanize your job. People tend to move a little bit out of the city as they age. In terms of commuting times, right? I mean, you see a big change here at the beginning of life, and then things are reasonably flat. And then you have, of course, a remarkable change in floor space consumption over time, which seems to be primarily driven by age and not so much by composition, which probably relates to the fact that as you kind of get older, you have higher wages because of more experience, and therefore you can also kind of afford larger flats. Something that I find striking, I don't know how the situation in Dortmund is, right? But looking at this here, the 20 years old, they consume about 40 square meter per person on average, right? I mean, this is by Berlin or even London standards, that's very generous, right? So in Denmark, people are fairly fortunate. Okay, so this is, that's a descriptive evidence. Now what we want to do, okay, this is just, that's the composite age effect, right? I mean, this is just a kind of a descriptive sense of where you live and what you consume, depending on how old you are. Now, of course, as you age, two things change at the same time. I mean, you have some change in preferences, which may be purely age dependent, but then of course, there is a stereotype life cycle. I mean, not everybody will have it at the same time, but everybody have children at the same time, right? But there is certainly a correlation with age. So what we want to do in the next step is we want to kind of get to a decomposition of the overall age effect into the pure aging effect and the life events effects, right? So how all else equal, do your preferences, do your location in the city change as you experience a change in your circumstances of life? And we're going to have a number of life events. The first one is going to be cohabitation. So you're moving together. You can have children. You can separate, right? I mean, after you move together, at some point you may decide to kind of try something else, so you separate. You have empty nesting, which is when the last child leaves the house. Then you have the retirement, and then you have the death of your spouse. And all of these life events, they can repeat, okay? So we're not going to have just the first cohabitation, we also have the second and the third, and not just the first child, the second child, and the third child. And then at some point you want to draw the line, in particular because we want to estimate the effect of one life event conditional on all the other life events, right? So we want to know something like, how does it change your economic behavior when you have a child, controlling for the fact that before you had a child, you cohabited, right? And that in some way, at some point, of course, limits the number of life events that you can account for simultaneously. So we draw the line somewhere. I mean, where you want to draw it, I mean, you can debate. We decide to ignore life events that occur to less than 2.5% of the population, right? So this means concretely that the first child is clearly in, the second child is clearly in. The third child, I think, is still in. So Danes, they are relatively fertile. So you have actually quite a few couples with 3 children, but I'm not sure whether the fourth child is still in, because it could be that actually less than 2.5% of the population have 4 children. For sure, the 5th child wouldn't be in, right? I mean, that's something that is rare even by Danish standards. And yeah, so now you may ask, Gabriel, how can you be so optimistic that you can actually identify all of these effects of these different life events conditional on each other, right? And the reason is that A, we have a lot of data, right? But then B, there's also a lot of heterogeneity actually when these life events happen, right? So what we've done here is just kind of to check actually, I mean, the distribution of ages when you have your first cohabitation, and you see actually many people start cohabiting actually at the age of 21, 22, but then there are actually some people who start cohabiting relatively late, right? And the same goes for when you have your first child, right? I mean, there is actually quite a distribution. And because of that, I mean, there's just enough variation in these different life events, right? If everybody basically had would kind of cohabit at the same age and have a child at the same age, then of course these two events wouldn't be separable. But because, I mean, in both distributions, right, I mean, there's a lot of heterogeneity, right? Therefore, it's actually econometrically pretty straightforward to identify them separately, right? I mean, that's something that, of course, you have to check. Yeah. And this is our regression equation now. I mean, are you familiar with event studies? Is that something you do in the statistics department, or is that too applied? The kind of panel event study. I mean, economists are obsessed with it. I mean, they use it for everything these days. If you go to an applied micro seminar, right, probably every week you would see one variant of this estimation technique. So you wouldn't have to spend a lot of words on that. But if that's what I'm asking, right, whether this is something which is totally normal for you. I mean, let me just kind of say what it does, right? I mean, so it's a panel econometric framework. You have an outcome here, which can be distance from where you live to the city center. Could also be something completely different, like the wage. I is going to be the index for an individual. T is going to be the index for time. You have the individual fixed effect. Here we have an age fixed effect, right? Just like before. And now we have a bunch of indicator variables which tell you how many years after a certain life event you are. For instance, you can have something like a dummy variable, which would be 1 if you are in the first year after you had a child. You have another dummy variable, which would be 2 years after you have a child, and so on and so forth. And you have also the leads. You have the dummy variables for the years before you have a child, 1 year, 2 years, 3 years, and so on and so forth. This is the one summation. So that's very, very standard, right? I mean, you have a bunch of beta coefficients. Each beta coefficient is going to give you the effect of being X years after a certain life event. The special thing here, you don't have that often here, right, is that you have a second summation, and that's simply because we're not just kind of estimating the lead and lag effects of one event, but we're estimating the lead and lag events of one event, holding the effects and all the leads and all the lags of all the other events constant. So this amounts, I think, to, I don't know, something like 900 dummy variables or something, because we have loads of leads, a lot of lags, and we have a lot of events. But then with 45 million observations, I mean, you don't worry a lot about how many variables you have in the data set, except that, of course, it takes some time to run the regression, right? I mean, this can take, can take a while. Yeah, I don't know. I mean, now there's a little bit of a nerdy discussion here going on, right? I mean, so in these distributed lag models, the discussion came out to say, okay, you need to be very careful about the implicit weights that you are kind of associating with your units as you have these many events happening. So there are remedies to this. To give you the intuition, we follow Borusiak et al. And estimate the effects of the covariates, right? So the individual fixed effects and the age fixed effects. We estimate these effects for the not treated and the not yet treated, right? So people who haven't really experienced the life events. And then we take these parameters and compute them for all the rest. Doesn't make any difference if you estimate it by OLS, you get exactly the same, right? I mean, but of course, for the nerds in the audience, right? I mean, that kind of follow this kind of literature, right? I mean, yes, we address the typical concerns, but OLS would be perfectly fine. So let's look at the first cohabitation. I think the intuition becomes actually relatively straightforward if we just interpret these results. We'll take the top left graph. What you see here is that before you decide to cohabit, right, your location where you live doesn't change very much, right? Then at the time when people decide to cohabit, they move a tiny little bit closer to the city center. So what you see here are log differences, right? I mean, this would be something like an 0.05 log unit decrease. You can dig a bit deeper into that. I mean, you can do insane amounts of things with these data. Turns out very often people move together and they find a new flat together, but sometimes people just move into one of the pre-existing flats, and usually they move into the flat that is closer to the city center, right? I mean, so you find a mate, right? You say, let's live together, and then there's a bargaining. I mean, are you going to move to my place? Am I going to move to your place? Turns out you move to the place which is closer to the city center because probably at this time of your life, you still feel like being in the city center is something cool. But then strikingly, very quickly, these couple discover that once they are together, they maybe go out less, right? And they use the amenities of the city center less. Instead, maybe they find out that sitting on the couch and watching Netflix is very convenient. And then they realize that, okay, I mean, honestly, sitting on the couch and watching Netflix, I mean, we can also do that in the suburb, right? I mean, there's no real reason to be in the city center and pay a very high rent, right? And then you start seeing this suburbanization of couples after cohabitation. And I say it again, this is not coming from having children. This is controlling for having children and controlling even for the leads of having children. So this even controls for the anticipation effect of having children. So this is a genuine cohabitation effect. So people change their preferences in certain important ways after they start cohabiting. This mainly affects the residents, not so much the workplace. Of course, if you stay working where you were and you start living further in the suburb, your commuting time increases. And here, something that's important for the counterfactuals, you see that when people move together, of course, they move into a larger flat, but in per person, in per capita terms, the floor space per adult decreases. And I think that's something that is important to note, right? I mean, we have this situation where we see house prices increasing in all big cities and most countries, and certainly in Germany, and you kind of wonder where does it come from. In the UK, people blame it on the construction sector. They say, okay, we don't build enough. In Germany, we actually build decent amounts. I mean, we could build more, but I mean, the construction is not disastrous. Still, prices go up. I'm not saying this is the only reason, but I think these results suggest that one of the reasons, right, why we can have increasing scarcity of space, even though we build enough and the population doesn't grow so much, is that we just have a lot more singles, right? I mean, if you look across cohorts, right, I mean, the fraction of singles increases dramatically. Partially, this is related to aging, right? I mean, at some point, I mean, you just kind of widow, and then you become a single, but even within the younger cohorts, you have more singles, and that pushes significantly your space consumption. And by the way, in case you haven't noticed, I mean, there are confidence bands everywhere here, right? They're just very small, because we have a lot of data. Now, you probably, some of you will probably challenge that our confidence bands maybe are not kind of super knowledgeably computed, right? But still, I mean, we have just a lot of observations, therefore confidence bands tend to be small. Children, now that we have kind of familiarized ourselves here already with the nature of the event study, that is easy to interpret. Main difference to what we saw before, having children is something that you can apparently anticipate. So you see people start suburbanizing even before they have a child, which is not surprising, right? I mean, some people try, right? Some people take tangible action to have children. I mean, most people know that in a certain amount of years they would like to have children, and they adjust their economic behavior even a little bit before, right? And and they continue suburbanizing until they reach a certain plateau. Now we have a bigger effect on the workplace distance, right? I mean, we see here that on average, right? I mean, after you have children, you also start suburbanizing your job. I mean, guess it. Is that mainly male or female workers who suburbanize the job, or both? In Denmark, if you look at the gender heterogeneity, it is actually the woman that suburbanizes the job, right? So you see that men, the kind of dark line here, right? After they have children, they stick to their jobs close to the city center on average, whereas women try to find jobs that are closer to the home, right? And my interpretation is that this might be related to childcare duties, right? That still, even though you see no effect on female labor force participation, which is amazing, right? I mean, in Denmark, couples give birth, and then you see absolutely no effect. Female and male labor force participation, if they change in a completely homogeneous way, right? But what happens is that the job choice, the locational choice of the job changes. Women suburbanize their jobs, and they actually end up in worse jobs. They end up in jobs that are less well paid, right? I mean, in Denmark, everyone is paid well, therefore I don't want to say badly paid, but less well paid for sure, right? And they are also in occupations which are less prestigious, I would say, right? And this is actually also the time when you start seeing a gender pay gap in Denmark. Before that, actually, you see no gender pay gap. It's really, and also only for the you only see the pay gap actually arising, of course, for women that get birth. I mean, that's not trivial, right? That's trivial, I would say, right? But I think that here, really, the gender pay gap, if you're interested in that is to a large extent related to the change in job location after birth, right? I find that quite interesting. Good. Yeah. So what else? Yeah, floor space per capita, per adult increases. So you have a child, you consume more space. That effect is relatively small, although you need to know that it's just the first child. You would have another impact on floor space consumption coming from the second child and the third child. If you add them up, right, on average, they have about 2 children per couple, right? Then the effect actually is not so small, even if you compare it to the cohabitation effect. Beautiful exercise, right? I told the story about moving together, cohabitation, and discovering Netflix, right? And we don't so often have in economics the reverse experiment. So do we see the opposite effect, the opposite treatment effect if we reverse the experiment? Here we have an instance where we can observe that. So what happens when couples separate, and then you see that suddenly they move back to the city center, right? I mean, so sitting alone on the couch watching Netflix is not fun, right? So you want to be in a place where you can do some interesting things if you're on your own. Possibly you want to get back to the city center to find someone new to kind of mate, I don't know, right? But certainly you move back into the city center. And I think you can still find a similar effect after the second separation, but after that separation doesn't have any effect anymore, right? I mean, it seems like at some point people are fed up, right? I mean, and say, okay, look, I tried it 2 times, it didn't work, right? I mean, maybe I'm not going to move back to the city center to find someone new, or you just get too sticky because you're old, right? I mean, but so separation effect is something that wears off in age, but the first separation surely has some significant effects on your economic behavior. And for sure here, as I mentioned before, right, I mean, if you separate, then per capita, right, I mean, you consume significantly more floor space, right? That's back to my story about the potential origins of the affordability crisis. At old age, relatively little changes, right? I mean, you can see here what happens when you become a pensioner. Nothing really changes. It's surprising, right? I mean, so that's interesting, especially against the backdrop of what you said before, right? That we saw the kind of effect on the propensity, on the likelihood that you move within cities. So maybe the story is that if you stay within the city, then you really don't move, right? But what can happen is that you may decide actually after you retire, you may decide actually to finally move to the nice kind of little town close to the sea or something, right? But you wouldn't see that in the within city analysis. Floor space doesn't change because you don't change the house, right? And the only thing that really happens when you become a widow, right? I mean, of course, mechanically you consume more floor space because now you have the house just for your own. Cool. So yeah, any questions on the event studies? No? Now you can ask the question, okay, so we have seen the overall effect of age, right? I mean, how our consumption pattern, our economic behavior changes as we progress in life. And we have learned that some of that certainly is coming from these life events. Now you can ask the question, how much is coming cumulatively from these life events? How much is coming from the pure aging effect? And then in order to do that, what you simply do is you kind of cumulate all these kind of estimated lead and lag effects of all these individual treatment effects for all these events. And then you can decompose the red dashed line. Let me remind you, when I say red dashed line, what I mean this line here, right? I mean the controlling for fixed effect line that tells you how conditionally, right? I mean, your economic outcome varies in space. You can take that line and we can now decompose that into a part that comes from life events, right? This would be this part. And then we have the residual component, which would be the pure age effect. It's a very simple mechanical decomposition, but it allows you to tell something about how important life events are relative to the actual aging, right? So this here again, is exactly the red dotted line you saw before. The thing about, okay, we start in the suburb. We have just normalized this here to 0, so that we have an index. You move to the center to kind of find a partner, maybe. Then we move out as we kind of cohabit and have children. And this is the cumulative effect of these life events, right? So you can explain, right? I mean, this upward trajectory here, right? That's basically coming from the life events. This is the effect here of kind of cohabiting, having children, and then separation works in the opposite direction. But clearly, over the life, the joint effect of life events is that they kind of decentralize your life. And then the pure aging effect actually is the opposite. So this is basically coming from the people who experience very few or no life events. Now you can argue, are these guys representative? Maybe not, right? People who really do not experience life events, they have the smell of being weirdos, right? I mean, must be a reason why they don't experience life events, right? But I mean, that's mechanically in the decomposition what it is, right? You could argue that, I mean, controlling for the life events, there is a force that kind of actually pushes you towards the city center, and then you stick there, right? Yeah, what else? I mean, distance to work, I mean, similar, but here the effect of life events is much less. Right, so I think the choice of the workplace is much more determined by general forces related to aging experience, much less to life events. And then for the floor space consumption, it's kind of a 50-50 split, right? I mean, a lot comes from aging towards the end, and life events play a bigger role, but I think that's widowing for the earlier years. I mean, aging, which is just another word for experience, is just a very important driving force, right? I think the way to read this is because you get richer, as you get better and better jobs, right? You consume more and more floor space, but then here you have people who on top of that have children, and then above and beyond this pure income effect, right? I mean, they consume even more floor space, right? And I think that's certainly potentially in an economic model a strong driving force why you would be moving to the suburb, right? Because of course, if you need more floor space, you might be looking for floor space in places where it's cheaper, and suburbs in terms of the unit price of real estate tend to be much cheaper than the city center. Cool, so I'm already starting a little bit talking about mechanisms. I'm going to skip this here a little bit in the interest of time. And now I want to shed some light, right, on the underlying mechanisms. What is driving people to change their location choices as they progress in life? We have different candidates, right? Yeah, since we are economists, right, our way to kind of do this kind of separation into mechanisms is by employing a quantitative model. So what is a quantitative model? Essentially, you rebuild the world, right, in an economic model. A quantitative model is not a pen and paper type of model, but it's a model that you can really fit to the data. So the economic model would explain the data partially through endogenous modeling mechanisms, and then the other part that you cannot explain through the endogenous forces of the model, you just load them onto a structural residual. It's like in the regression equation where you say, okay, y is a function of beta and x plus a residual. In a quantitative model, this beta times x is just a very sophisticated, complicated, nonlinear multi-equation model that seeks to solve for the general equilibrium on labor, housing, and goods markets, right? So it's just a more complicated data generation process than you have in the standard regression. And yeah, so let me show you some features here of that model. So we have a city that consists of various locations. So it's not like a standard, a stylized model. The city is not a line, the city is not a circle, but the city consists of really concretely observed neighborhoods in Copenhagen. They are connected through a transfer technology, right? So we compute the transfer cost from getting from any neighborhood where you could live to any other neighborhood where you could work, right? We have workers and non-working people, right? We have these people choosing where to live and choosing also where to work if they work, okay? They consume a finite good and floor space. And this is importantly, right? These workers belong to different groups. people with children, people without children, people who are married, people who are not married, and they have different preferences for the same neighborhood. So one neighborhood could be a neighborhood that would be appreciated by people with children, and by people without children, this neighborhood wouldn't be appreciated at all, right? We have firms, kind of, they produce floor space, and the trader will find the goods. That's kind of all very standard. An economic model kind of uses utility functions like this. I mean, if you're statisticians, I mean, you won't find that super informative, maybe, or not super interesting, but let me give you the gist of it. What we're saying is that our agents, they have a higher utility, they are happier if they earn higher wages. They're going to be less happy if they pay higher prices, if they pay higher rents, and if they face larger commuting costs, right? And then what we do within the model, we compute the optimal locational choices, right, that these agents do. We think about, okay, firms have to hire people, right? They have a production function. We clear the labor market, right? We can derive location choice probabilities. What this means is that the model is going to tell us where, in what, how, I mean, so this is basically telling us here what fraction of a certain group is choosing a neighborhood N, depending on amenity values, depending on floor space prices and wages. I mean, this is kind of an economic model of location choice, right? And now what we can do with this model, I'm going to skip this, I mean, to make this not too kind of, let's say, boring, but the key idea is, after you estimate all these parameters, you kind of use the model to estimate housing supply functions, you use the model to estimate labor supply elasticities, everything by group, right? I mean, you estimate gravity, commuting parameters also by group. I mean, this is really a kind of a comprehensive quantification exercise, much broader and much more ambitious in the sense of between worker group heterogeneity than we have done in previous models. After you've done all of that, what you can now do is you can decompose the locational choice in the model into, let's say, yeah, I mean, you can basically, yeah, eventually what you want to do, you can separate the contributions within the model, right, to the location choices into these different economic mechanisms, right? And what I'm going to show you here is just a descriptive illustration of what we find, right, through this decomposition. So one hypothesis is that, okay, the reason why different family types live in different places in the city is related to the amount of money they spend on housing. I think that's very intuitive, right? I mean, you have children, you need a bigger house, okay? If that was the case, what you would expect to see is that people, right, who spend more money on housing, they should live in the periphery. They should live far out, right? Because far out, it's much cheaper. What you see, it's the opposite, right? People who have a high expenditure share, they live actually in the city center. So even though they should actually live in the suburb, they live in the city center. So it cannot be this kind of housing expenditure that forces people to live in the suburb. What else could it be? Commuting cost aversion, right? We kind of back out from the data, right? I mean, what the perceived commuting costs of these people are, right? Of course, if this is coming from commuting costs, you would expect people who do not like to commute, right? They should live in the city center. It's the opposite, right? People who hate commuting live in the suburbs. So it must be something else. What's the answer, right? You take the model, you say, okay, model, please control for labor demand, control for labor supply conditions, control for commuting costs, model control for housing expenditure, and then just kind of load everything you cannot explain, load that onto the residual value that gives you kind of some group-specific appreciation of certain places. And what comes out in this decomposition is that the reason, of course, in the model here, right, I mean, under the assumption that the model is correct, I mean, the reason why certain type of people live in the suburbs is because they like the amenities in those suburbs, right? And if you want to ask what these suburban amenities are, right, I mean, we started to run some regressions, they're not here, but you can tell that it's actually access to nature, access to playgrounds, access to parks, right? And certain people who live in the suburbs just turn out to have the highest willingness to pay for these suburban amenities, right? And yeah, so this is just an illustration. I mean, that just shows you the relative preferences of young and old that you can do in the model. but rather because I think I shouldn't do more than 60 minutes here, right? Let me just kind of move to this last exercise, right? Where I kind of just show you some simple counterfactuals, what's going to happen with the city of Copenhagen as we change the composition of workers in the city. So that is something I think which is interesting from a planner perspective. So what we're doing here, we have this model. In this model, all these groups are competing for space. Okay, and now you just take the model and you say, okay, look, I'm holding all these parameters that I've estimated constant, and I'm changing the composition. I'm just having now more people, for instance, who are old, fewer people who are young. And do the same thing, have more parents, fewer non-parents, you can have more singles and fewer singles, right? And then you can say, okay, now model, find me the equilibrium, right? I mean, with the corresponding adjusted prices, wages, and so on and so forth, right? That constitutes this counterfactual equilibrium. So this is a what happens if question here. So you ask the model based on our parameterization, if the share of old people increases by 10%, how is the city of Copenhagen going to change in terms of residential population? Well, people get older. Older people like the suburbs better, right? So you see a bit of red in the residential population choice in the downtown. People move from the city center to the suburbs. The effect is going to be even more pronounced on workplaces, of course, because old people don't work. So you really see total employment in the center going down. And correspondingly, you see floor space prices in the city falling because, of course, you're going to have less demand for floor space in the city center if people get older, right? And I think that's the conventional perception that planners have. If you talk about how's the city of the future going to look like, they feel like, oh, okay, I mean, maybe our suburbs are going to do well, but the city center could actually die if you only have old people, because old people don't like to be in the city center. But then something that's happening at the same time is we also have a lot more singles, right? And singles, they really have a strong preference for being in the city center. So essentially, this trend, according to our forecasts, right, is more or less kind of canceling out this effect of aging, right? Very little effects on employment, and then here also very little effects on floor space, right? These are estimates that I'm showing here for Copenhagen. You may not be interested in Copenhagen, but I think the key interesting thing is that we have a quantitative framework in which you can do these simulations for any type of city in the world. And I have to do them for any type of city, because in any type of city, you're going to have different combinations of aging, changes in fertility rate, changes in singlehood. So the simulations are going to be very city specific, right? But that's a framework that planners can use. I mean, it's informed by these estimates. Actually, I didn't spend much time on kind of talking about these estimates, right? But they're informed by the data from Copenhagen. Of course, you need to be willing to believe that there is some external validity in the parameter values. But to the extent that you're willing to believe that, you can use the modeling tool to kind of get an idea of how the city of the future will look like. And as I said initially, more likely than not, these mega trends probably will cancel out in the way that the city is going to be relatively resilient. And I think with this, I have exhausted more of my time than I actually was allocated. And I thank you very much for your attention, and I stop here.